Alright, from here now, we want to start getting into nomenclature. Because there's new nomenclature because the alkene is a new functional group. But also, we have some nomenclature that's very specific to alkenes. So when you've heard of unsaturated fatty acids, you may have heard some other terms used as well. Those other terms you may have heard are cis and trans. So those also directly relate to the structure of the molecule. Now, what do they actually mean? So here's a double bond, and we're going to look at an alkene that has just a methyl group on each side. We could draw it like that, or we could draw it in that way. So both of these are 4-carbon chains. Both of them have an alkene in the middle. Are they the same compound? Well, if we were dealing with alkanes and there was no double bond here, and we drew them like this with an alkane, alkanes have free rotation, and so that bond could rotate, and these two are the same compound. If you have a model kit, you might want to get your model kit out and put butane together and convince yourself that you can sort of twist about that middle bond, and you can get either of the two structures pictured here. But with the alkene in there, no rotation. And so these are different molecules. Now the one on the left has the hydrogens on the same side, and it also has the carbon groups on the same side. The one on the right, the hydrogens are on opposite sides. So when they're on the same side, we call this cis. When those hydrogens are on opposite sides, we call them trans. And sometimes we use cis and trans as our nomenclature. Again, we see it with fatty acids all the time. Cis fatty acids and trans. And the difference is just how the double bond is arranged. So if you go back to what I did earlier, this example of a fatty acid would be considered cis. And then if the double bond was the other type, like that, then that's what would be considered to be a trans fatty acid. So in that context, this cis and trans works well for nomenclature. But for a lot of molecules, cis and trans isn't sufficient. And the reason it's not sufficient is once we get more than 2 substituents on our alkene, which isn't hard to do, that sort of concept of cis and trans just doesn't really make any sense anymore. And so we need another system of nomenclature that's going to let us name a compound or name the geometry on one like this. So what we use is known as the EZ system. And there's a lot of this that's familiar to us from what we did with stereochemistry in the previous section. Now, we're going to use it a little bit differently, but the whole idea of assigning priority is something we'll do again here. So what we're going to do is just kind of break this molecule in half. And we're going to do that in the middle of the double bond. Now, let's focus on the left side first. The carbon on the left of our alkene is bonded to two things. It's bonded to a bromine, and it's bonded to a methyl. So what we have to determine right now is, of those two groups, which one is higher priority? And how do we do that? Well, if you recall from our stereochemistry section, we said that priority is determined on the basis of highest atomic number. So bromine is higher atomic number than carbon. So the bromine on this side would be first priority, and the methyl would be second priority. What about on the other side? So on the other side, we do the same thing. That carbon has two substituents, a chlorine and an OH group. And so again, our question is, which one is higher priority? Chlorine has a higher atomic number than oxygen, so chlorine gets higher priority. All right, so that's the first half of using E and Z. What's the second half? The second half of assigning E or Z now looks at where the higher priority groups are. So for this alkene, are the higher priority groups on the same side, or are they on opposite sides? And we can see here our higher priority groups are on the same side. So if they're on the same side, this time instead of using Latin, we go to German, and we use the German word for same, and we abbreviate that with Z. So this alkene in this molecule would be considered to be Z. Okay, let's look at another example. So let's do the left side first. We have iodine and we have hydrogen. Well, we know that hydrogen is always lowest priority. And iodine, of course, has much higher atomic number than hydrogen. So we have 1 here and 2 here. What about the other side? Well, initially, attached to a carbon, attached to a carbon. So those are the same. So now the question becomes, what are those attached to? So this carbon is attached to 1 carbon, but the carbon here on top is attached to 2 carbons. So that makes it higher priority. So 1 here, 2 here. So now our higher priority substituents are on opposite sides. Again, using the German word for opposite. that would define that double bond as E. So let's just do a couple more. So perhaps at this point, maybe pause the video for a couple minutes and try and determine E or Z for the two alkenes I've drawn here. All right, so let's look at them now. The alkene on top on the right side, we have a chlorine, which is higher priority than the carbon. What about on the left side? On the left side, we have a methyl, and we have another methyl. Well, that would actually be the same. So we can't assign priority there because the two groups are the same. And so for this example, EZ does not apply. What about the one at the bottom? The one at the bottom, on the right side, we have bromine, which is higher priority than carbon. On the left side, we have a methyl versus an isopropyl. So the methyl is a carbon bonded to 3 hydrogens, whereas the isopropyl, that carbon is bonded to more carbons. So higher priority here than here. Our ones are on opposite side, and so that means this alkene is E.